Hey everyone, in this video we're going to be talking about how do we graph quadratic functions in standard form by using a table. This doesn't really have to limit to quadratic functions. You basically are going to learn today how to use a table to graph literally any graph, as long as you guys follow the steps. But in these examples, we're going to be limiting it to parabolas or quadratic equations, another way of saying the same thing. So graphing quadratic functions or quadratic equations in standard form by using a table. Okay, so just to recap, a parabola is the name of a shape that a quadratic function takes shape when graphing. It will always be a symmetrical U shape, either facing up or upside down. So ideally, when A is positive, so when you guys have the value of A that is positive, you're going to have a quadratic equation or a parabola that is facing upwards. And when it is negative, you're going to have a quadratic equation that is facing downwards, like so. So when A is positive, the quadratic equation, the graph will look kind of like a U facing upwards. And when A is negative, the quadratic equation will look upside down. Basically, it's the same idea, but we're going to be having a U upside down. And it's still going to be symmetrical. So this is what this represents. If you're wondering what it is that we are talking about. So for a quadratic equation in standard form, this is what the formula looks like. For a standard form equation, f of x is equal to ax squared plus bx plus c. Now, all these numbers are important in some way, shape, or form, as we will discuss in future lessons. But for today, all you really need to know is the a value. So this a value, the number that's in front of the x squared, really important, right? So it really pay attention to where the x squared is. So the number that's in front of that, the coefficient, will determine whether it's going up or down, and a couple of other things that we're going to discuss in the future. But when a is positive, the parabola will be like a regular u. When a is negative, the parabola will be upside down, like an upside down u. Okay? So that being said, how do we actually graph parabolas? By using a couple of things that we already know from past lessons. So the first thing that we're going to be discussing is the y-intercept. So the y-intercept, as we discussed in a prior lesson when we graph lines, is the point in which the graph crosses the y-axis. And the trick to knowing what to do with the y-intercept, if you want to find the y-intercept, all you have to do is you set opposite, right? X equal to 0. That is always going to be the case. It was the case with lines. It's going to be the same case with quadratics and any other function you're going to get in either math 1, 2, 3, 4, any math class. So if you want to find the y-intercept for a function, you set the x equal to 0, because by definition, the y-axis is the line x equals 0. So these two are interchangeable, right? The y-axis and the line x equals 0 are the same thing. So when you want to find the y-intercept, you set x equal to 0. Okay, the last thing you need to know is the order of operations. So please excuse my dear Aunt Sally. That is very important when you guys are trying to identify what are the values in the tables when you guys substitute for the x. So you should already know this by now, because I'm pretty sure some of your other math teachers have already drilled this into your brain by now. But PEMDAS, right? Please excuse my dear Aunt Sally, which is an acronym to figure out what goes first when you're doing operations in mathematics. So the first one is parentheses. The second one is exponents. The third one is multiplication. The fourth one is division. The fifth one is addition. And the last one is subtraction. So please excuse my dear Aunt Sally. Basically, the ones that people get messed up the most are the following two, E and M. So parentheses, they remember, division, addition, subtracting, they remember, but this is the part where they messed up. So when you guys have something that looks like this is what I mean by that. So for example, let's say you guys have 2 times 5 to the power of 2. Okay, so let's say you guys have something like that. If you guys set the answer to be 100, you guys are 100% wrong. That is not going to be 100. This is wrong. And this is the part where people mess up usually when they don't follow the order of operations, especially when we're doing quadratics. So what you want to do is first you want to take the exponent, which means you have to take the power first, right? That means that we square the 5, so 5 to the power of 2. Remember, it's 5 squared, not 5 times 2. So when you're squaring the 5, you multiply that 5 by itself twice. So 5 times 5 will give you 25. So the actual answer is 2 times 25, which will give you the value of 50. Those of you guys that thought that the answer was 100 probably did the following. You probably did 2 times 5 and then took that as a square. So 2 times 5 and then basically did 10 times 10, right? Which gives you 100, which is incorrect. So the first thing you need to do is first do the exponent, which square it, and then afterwards you multiply. And if you remember those two steps in that order, then you will get these problems correct. Okay, as long as you simplify correctly. All right, so let's go through one example that you should already know how to do, is graphing a line. So let's say we want to graph a line, right? So the equation of the line is y equals 2x minus 3. So now this equation, we've done this in the past, 2x minus 3, that is going to stay the same. The only thing that I'm going to be changing is the value of x. And the value of x corresponds to the value of x on the table on the left-hand side. So all I'm doing is I'm changing the values of x's, or the values of x, in this equation so I can figure out the value of y. Okay? And the value of y is what we don't yet know. But all we're doing is substituting. So when we plug in the x, we get our y for every single one. So on the first one, we're going to plug in x equals 5. On the second one, we're going to plug in x equals 2. Third one, x equals 0. And then fourth one, x equals negative 1. So we're going to be substituting these in and figuring out what the answer should be for each one of the values in the table on the right side. So 2 times 5, we multiply first, right? 2 times 5 is 10. And then we subtract 3. The first value is 7. So my first answer is going to be 7 here on the right-hand side. We do it again for the next one. 2 times 2 is going to give me 4. 4 minus 3 is going to give me the value of positive 1. So my second value is 1. We do it again. 2 times 0 will give me 0. We're going to subtract 3, so that'll give me negative 3. So my third value will be negative 3. And then finally, we plug in negative 1 or substitute. We get negative 2 minus 3. They're both negative, so we have to add them up, right? The sign stays the same. The answer will be negative 5. So then my last value would be negative 5 for this. So that's it. That's the hard part. All we have to do now is graph it on the bottom of that table, and we already have all the points. So basically, every single one of these points we're going to have to graph. Let's start with the first one. First point that we're going to graph is x equals 5, y equals 7. So we're going to go to the right 5, 1, 2, 3, 4, 5, and then up 7, 1, 2, 3, 4, 5, 6, 7. So it's going to be up there outside of the table. Don't freak out. It's okay. Next one is 2, 1. So 2 to the right, and then up 1. That'll be right there. The next point will be at 0, negative 3. So we don't go left or right. We stay in the middle. That'll be 0. And then we go down 1, 2, 3. So this will be my third point. And then my final point will be this one, which is negative 1, negative 5. That means we go to the left one, and then also we go down 5. 1, 2, 3, 4, 5. Okay, so negative 1, negative 5. When we actually connect all these points, yeah, these numbers are like scattered around, like they give you some random values. But essentially what we got is that all of these points fall under the same line, and which is corresponding to the y equals mx plus b. Now, I did it using a table, right? We did it using a table because that's what we're going to be doing in this lesson for when we're doing quadratics. But we could have also done it the old-fashioned way because we already know how to graph lines, right? So using y equals mx plus b. So if you want to verify that equation real quick to see if it works, the b would be the y-intercept, which in this case is equal to negative 3. So we start at the negative 3 on the y-axis. The slope in this case would be the number that's in front of the m, or the x, I'm sorry. So that m would be equal to 2, which I'm going to say that 2 is the same thing as 2 over 1. So we start at the negative 3, and we go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, over and over again. We can have as many points as we want, and it will still give us the same line. So once we connect all the dots, as you can see, the more dots you have, the straighter your line will be. So you can see that these two are the exact same thing, right? So this sign and this sign are identical, but we graphed it two different ways. This one was using a table, right? So we use a table to be able to graph. And this one is using the formula y equals mx plus b. Either way, we get the same answer. Now, the only problem with this is that when they give us something different, like if they gave us a quadratic, we don't really have an easy way to graph it yet. We're going to have an easy way to graph it in a future lesson, or a different way of graphing it, but it is a lengthy process. So for right now, we're going to be graphing them just by using a table of values. And the table is already given to you. So let's just practice simplifying and graphing it. Okay, so this is example number 2 out of 3. So how do we graph this? So the first thing we're going to be doing is every single place where you see an x, we're going to be having a blank. So as many x's as you have, that's as many blanks as you're going to have when you're simplifying. So I'm going to go ahead and write x squared, which will be blank squared, plus 2x, which is 2 times blank, minus 7. And then we're going to just keep going that way all the way through, just so we can save ourselves a little bit of time. And then eventually we can just plug it all in. So something squared plus 2 times something minus 7, something squared plus 2 times something minus 7, something squared plus 2 times something minus 7. So all the way down. Yeah, they're going to give you a bunch of different points. You're going to be substituting these points, simplifying, and then once you're done with simplifying, you basically just graph the points that are left around that table. Okay, so let's see what we got. So on the first one, we have to plug in -5. So in this blank, we're going to substitute that blank for -5. Now be careful with the order of operations, right? First, you do parentheses, then exponents, then multiplication, and then finally you add and subtract. So exponents first. Let's do -5 squared is -5 times -5, which is positive 25. In the middle, we have 2 times -5, which is -10. So I'm going to put minus 10. And then we had a minus 7 in addition to that. So the final thing would be 25 minus 17. And 25 minus 17 would give us 8, I believe. Yeah, so the final answer for this will be positive 8. So on my y value, I'm going to write just the number 8. And then you're just going to keep going all the way down through the next one. So make sure you listen to or pay attention to the order of operations while you're doing this. So next number we're going to plug in is -4. We're going to be substituting the -4 into. We get -4 times -4, right? That'll be positive 16. And then 4 times 2 times -4 will be -8. So we're going to put minus 8 in the middle. And then finally the minus 7 that was there from the original equation. 16 minus 8, that'll give me 8. And then we still had that -7, right? So 16 minus 8, that gave me that number. Then we subtract 7. So 8 minus 7 will just be 1. So my next answer will be positive 1. And then we just keep going. So we are going to have more values, but you'll eventually see a pattern once you get towards the end. So -3, plug that in, -3, -3. Trying to figure out, okay, what is -3 squared? 3 times 3 is equal to 9, so that'll be 9. 2 times 3 is 6, and that's a -3, so it'll be -6 in the middle, and then minus 7. 9 minus 6 will give me a total of 3, and then we have to subtract 7. 3 minus 7 will give me -4. So my next answer is the value of -4. Okay, now we're going to plug in -2. So same thing, go down the list, plug in -2 to everywhere you see an x. -2 squared is positive 4. 2 times -2 is -4. And then we had that -7 still. 4 minus 4 gives me 0, so it cancels out. All we have to do is take 0 minus 7, which is -7. So the next number would be -7 on the list. Okay, so by now it should be pretty repetitive. So next we're plugging in -1. Plug in -1, -1. 1 squared is just 1. So that'll give me 1. 2 times -1 is -2, and then subtract 7. So 1 minus 2 is going to give me -1, and then we still had that minus 7, right? So -1 minus 7 will give me -8. So -8. Okay. Keep on going down the list. So the next one will be 0. So what happens when we plug in 0 for x? So 0 goes 0, 0 goes there. The great thing about that is that everything really goes away when you plug in 0. You get 0, 0, and then minus 7. So the answer for that would be just -7. I'm not even going to bother with the word because everything goes away. Okay, so on the next one, we're going to plug in the number or the value of positive 1. So same thing here and here. So 1 squared is just going to give me 1. 2 times 1 is going to give me 2, and then we got to subtract 7 to that. So that'll give me 3 minus 7, which is equal to negative 4. So the next one will give me negative 4. Keep going down the list. We're almost done. So when we plug in 2 into that, same thing. We got to square the 2 and then multiply 2 times 2. So 2 squared will be 4. And then 2 times 2 will also be 4. So that'll be 4 plus 4 minus 7. 4 plus 4 is 8. So that'll give me 8 minus 7, which is going to give me the final answer of positive 1. That's a 1, by the way. It looks like a 7. There we go. Okay, the last number that they give us on the table is a positive 3. So we're going to plug in 3 here and there, substitute. Some teachers don't like the word plug in, so they say substitute. I don't really care that much. But if it bothers you, substitute or plug it in. So 3 squared is going to give me 9. 2 times 3 is going to give me 6. And then finally, minus 7. So 9 plus 6 is 15. And then minus 7 is going to give me the value of 8. So there we go. So we have the value of positive 8. Okay, so this looks all kind of nuts, right? So we had to plug in a bunch of stuff to be able to get all the answers. But what we do know is that this right here is the standard form equation for a quadratic function or a parabola, right? So we established in the beginning of the lesson that for a parabola is ax squared plus bx plus c. We also established that the a, the number that's in front of the x squared, determines whether it goes up or down. In this case, the number that is in front of the x squared is the value of, even though they don't write it, it's 1, right? Positive 1. So we know one thing. We know that it's going to be a parabola, right? Because that's the standard form equation for a parabola. And we also know that it's going to be pointing upwards. So if you don't get something that looks like this, then you know you did something wrong. So you might want to check your work, check your simplification, make sure that it looks perfectly like a U going upwards. And if it doesn't, you did something wrong. So go back and check your work. It's usually pretty obvious the one that you messed up on whenever you don't get the correct shape of the graph. All right, now we just have to graph the points. So let's go down the list. So let's graph the first one. So this first one right here is negative 5, positive 8. So we go to the left 5, starting in the middle, 1, 2, 3, 4, 5, and then up 8, 1, 2, 3, 4, 5, 6, 7, 8, which would be right. Wait, this is weird. These numbers are kind of weird. 1, 2, 3, 4, 5, 6, 7, 8. There we go. The next one is negative 4, positive 1. So to the left 4, up 1. The next one is to the left 3, down 4. So 1, 2, 3, 1, 2, 3, 4. Okay, the next one is to the left 2 and then down 7. So we go to the left 2. Let me scoot down a little bit so you guys can see the bottom. So to the left 2, down 7. 1, 2, 3, 4, 5, 6, 7. Okay, next up we have to the left 1, down 8. So negative 1, down 8. Next we have 0, negative 7. So we stay in the middle and we go down 7. So that'll be my next point here. Next up we have 1, negative 4. So we go to the right 1 because it's positive and then down 4. And then next we have 2, positive 1. So we go to the right 2, but we also go up 1. And then the last point that we have is to the right 3, up 8. So 3 to the right, up 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There we go. You should notice something, right? So our prediction was correct. We said that the graph is going to be going upwards and it's going to look like the shape of a U. And if you notice, when I connect these points, that's exactly what it gives us. So it gives us the parabolic shape, which is basically like a U facing upwards, right? So if I connect all these dots, make sure that you make the bottom curvy. Like it should not look like a V, it should look more like a U. So this is the final graph. So it's basically a parabola going upwards. It's a positive parabola going upwards. And you have completely graphed it on your own by using a table of values. Okay. I only have one more example for you guys, and then you guys can practice the handout on your own. So this time I decided to be a little nicer to you guys. I didn't give you as many points, but it's the exact same process. So let's go through graphing the parabola. So we're going to be taking everywhere you see an x, right? Everywhere you see an x, and we're going to be plugging in or substituting the value of the table, whatever it gives us. Now this equation is going to change a little bit. The first one is going to be -2 times blank squared minus 4 times blank minus 5. Remember, everywhere that I see an x, I'm going to put a little blank because I'm going to be plugging in the value of x from the table. So the next one is -2 blank squared minus 4 times blank minus 5. Same thing. Next one, -2 times x squared minus 4 times x minus 5. A couple more times. All right, 2 more. This is going to give me that forearm strength from all this writing over and over and over again. Okay, so now we just have to plug in the values of x. So we know that the equation is -2x squared minus 4x minus 5. We want to simplify that by using this table of values. So the first thing we're going to plug in is -2. So plug in -2 into the first 2 slots. When we do that, remember the order of operations. First, parentheses, then exponent, and then we multiply, right? So be very careful when you do this. So -2 to the power of 2 will give you 4. So this will give me -2 times 4. And then on this side, we get -4 times -2, which is +8. And then minus 5. So if you're wondering where I got this value from, this 4 came from me squaring the -2 to the power of 2. Then we can simplify, right? Now we could actually multiply this out. So -2 times 4 is -8. And then we also had a +8 and then minus 5. So the final answer is -5, right? Because the 8 and the -8 cancel. The first -8 came from the multiplication of -2 times 4. Okay, so we just got to keep going down the list. So that's our first answer, -5. So let's write that down on the table. The y should be equal to -5. And then moving on to the next one. So now we have to plug in -1, same idea. Plug in -1. Be careful though. Make sure you follow the order of operations. First you have to square it and then you multiply by the number in the front. So in this case, we have -2 multiplied by 1 and then -4 multiplied by -1. We forgot to put the -1 there. So that'll give me a +4 and then -5. So when I multiply these out, like I said earlier, this came from me squaring the -1. I get -2 plus 4 minus 5. And then when I simplify that out, a final answer would give me -3. So the second simplification would give me the value of -3. Okay. The next one is pretty easy because we're plugging in or substituting the value of 0. So when we plug in 0 here and here, everything goes away except for the -5. So that'll give me the value of -5. Okay, so then -5 is the next one. Let me double check something real quick. 4 plus 8. Yeah, everything seems fine. Okay, I thought I did something wrong, but I think everything seems pretty good. All right, so next we have the value of 1. So when I plug in 1 into the function, I plug in 1 here and there. When I go ahead and simplify this, I get -2 multiplied by 1 minus 4 minus 5, which is equal to -2 minus 4 minus 5 will give you -9, right? So that will be -11. So my next answer would be -11. So keep going down the list. The next one that we're going to plug in is equal to 2. So the value of 2. When I simplify that out, I get 2 squared, which is 4. So again, I'm squaring this first, right? So 2 squared is 4, and then I multiply that by the number in the front, which will give me -8. So this time I'm going a little faster because I kind of got the hint of it already. the hang of it. So it's going to be negative 16 minus 5, which is going to give me negative 21. So the next one should give you negative 21. Okay, so I don't have a table that goes all the way down to these negative values, so I'm just going to go ahead and graph what I see now and then go from there. So as we can see, I didn't fill out the other tables yet. I'm going to go ahead and do it just to say that I did it. But if you get a table that doesn't actually fit in the graph, just don't graph it. It won't be a big deal. You basically just don't graph the ones that don't fit. So in this case, we get 9. 9 times 2 is 18. So this will be negative 18 minus 12 minus 5. That'll give me 30. Minus 5 is negative 35. So this will be negative 35 on the next one, which again, it will probably not fit in the graph. And then if I do the next one, which is 4, same idea here. 4 times 4 is 16. 16 times 2 is negative 32. Minus 4 times 4, which is another 16. Minus 5. So that'll give me 48. 53. So negative 53, I believe. So anyways, the last two numbers that are on the table are 100% verified, but most likely they're not going to fit because, like, as you guys can see, the table only goes from negative 10 to positive 10. So let's graph what actually fits. So first thing we need to graph is the point which is located at negative 2, negative 5. So we go to the left 2 spaces and then down 1, 2, 3, 4, 5, which is this first point right here. The next point that we're going to graph is negative 1, negative 3. So we go to the left 1 and then down 3. The next one that we're going to graph is at 0, negative 5. So we go 0 and then down 1, 2, 3, 4, 5. Okay. The next point that we're going to graph is 1, negative 11. So we go to the right 1 and then down 11, which is going to be right off the graph, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it'll be right about there. The other ones won't fit. So as you can see, that kind of gives me the shape of the parabola. In the beginning, we have the equation y is equal to negative 2x squared minus 4x minus 5. But we only really care about the value of a. The value of a is the number in front of the x squared. This is a negative number, right? So whenever we have a negative number, we know that it's going to be a parabola that is going to be upside down. So it's going to look something like this because the a is negative, or the number in front of the x squared is negative. Now, by looking at my graph, I already kind of see the shape, right? So my parabola actually looks something like this. If I reflect this on the other side, so this is the highest point, and then it goes all the way back down on this side. So all I need to do is make the arrows, and then I have successfully graphed the parabola. So just to let you guys know, in this example, a lot of these numbers that are right here are unable to be graphed because they're outside the page. That was a mistake on my part because I should have verified them a little better before I give you guys this example. But on your assignment, you're actually going to have points that are all on the graph. So I'll try to make sure that that is the case. Okay, so essentially the process is still the same though. You basically just plug in the numbers and substitute the values, figure out what the answer should be once you simplify, and then make sure you make the prediction and verify your prediction with the graph. Okay, hope this video was a little bit helpful. See you guys on the next one. Good luck.